Okay, welcome everyone. Can everyone in the back hear me? Excellent. I'm glad you're here today, and it's nice to see a room that's full. Who was at the party last night? Who had fun at the party last night? Oh, most people, some people. Who's happy that this session is not at 9 a.m.? All right, the people who had fun are happy. Okay, that's good. That's good. Well, today we're here to talk about mobile broadband and how to build a metro-style application for devices that connect to mobile broadband networks. This is a new feature in Windows 8, and we're looking forward to talking about it with you. Oh, I think I'm going the wrong way. There we go. My name is Samer Sawaya. I'm a program manager working on the Devices and Network Experience team in Windows. I work on the mobile broadband user experience for Windows 8. And I'm also going to introduce my colleague, Dheeraj Gandhi. He's here in the front row. He's a program manager on the wireless networking services team in Windows. And he'll be joining us later to talk about how to implement some of the scenarios for this feature. So let's get started. Many of you might be familiar or have attended some of the talks around the device platform for Windows 8. This feature is an extension of the device platform. What we've done is, instead of using devices to connect a metro-style experience, we are abstracting the device concept, and we can figure out, when you plug in mobile broadband devices, we can figure out who the network operator is for that mobile broadband device. And we can associate a metro-style experience with that operator. And so it's built on the device platform. We're going to talk today about what are the key scenarios you need to think about when you build your mobile broadband metro-style app. There's a set of key scenarios that we think are important for completing the scenario. And after that, Dheeraj is going to come up, and he's going to talk about how to actually implement the scenarios using metadata and our APIs. The main thing we want you to take away from this talk is that Windows has invested a lot in the mobile broadband platform, and we've also invested in ways for you to differentiate and show your unique experience to your customers. The feature is targeted towards mobile network operators and to ISVs who are developing apps for the mobile network operators. Somehow the mobile network operator is part of that equation. So part of this platform for differentiation that we've enabled, one of the things we've done is that we've allowed mobile network operators to show their brand in the Windows Connection Manager. This is the Connection Manager that comes with Windows 8. We think that that way users have a predictable way to get connected. At the same time, we will allow the network operator to show their metro-style app and link to it from the Windows Connection Manager. A part of this is that when the users connect for the first time using the Windows Connection Manager, we know to launch the operator metro-style app and allow you to present your own purchase experience or your top-up experience or whatever way you get users onto your network. We also allow you to show users information about the data usage that they've used. That's a key scenario. This is done through the metro-style app and through the notifications framework that's in Windows. And one of the key things we think is that we help you to show the key services and the value-added offerings that you have as a network operator to customers. So it's really easy for me just to talk about these things and just discuss them like this. But we're going to take it a step further. we're going to have John Sharp from AT&T. We've worked closely with them to build one of these Metro-style mobile broadband apps. And John is going to come up, and he's a principal product development engineer. He's going to come up and talk to you about the work that AT&T has done on this platform and discuss some of their findings. So John, come on up.
Am I good? Can you guys hear me? I'm lit up? All right. Thanks, Sam. I appreciate it. Guys, excuse my voice. I've been so excited about Windows 8 and screaming it to everybody. I've lost it. So, Sam, thanks for the introduction. As fancy as my title sounds, I'm basically a product realization manager. I help bring products to market basically as our internal customer, the business development folks at AT&T that work with the different OEMs to bring a new laptop to market or a new tablet to market or even a new handset. I work with a development team that writes code to integrate what we call AT&T Communication Manager. If you guys are familiar with that, it's traditionally the dongle or maybe a notebook or a netbook that has an integrated radio or maybe, like I said, even a tethered handset. And that world for us today is wildly complex, time-intensive, and you talk about integration and certification timeframes. So it's very costly and it's very timely for us. And I want to show you guys kind of how Windows 8 is really going to revolutionize that world for us and that space. As we take new devices in, it's a one-to-one relationship. So if we ship 12 laptops by the same manufacturer, odds are we'll need 12 versions of ACM to work with that product. We'll need to integrate a specific driver. We'll need to communicate to that specific firmware level. We'll need to have specific AT commands that module will respond to so that we can get the answers we need to operate successfully. That changes anywhere in that process. As we're going through and there's a radio problem and the firmware needs to spin, we've got to start over our certification process. So that's kind of my life currently, and it's very complex and it's very time consuming. Obviously for us, time to market is key. So any of those delays puts me in the hot seat. So I want to show you guys kind of live some of the great work we've done with Microsoft. Granted, it's been a very easy process, and I'll go into some of that detail later. We've been, I joke, but we've been on Microsoft campus for months now working in an underground bunker, and we're really excited to see this live, and hopefully, has everybody activated? Anybody not activated the device yet through this process? No, not a lot of hands. All right, so just keep your eyes on the right-hand screen there. I'm not going to do both screens quite yet. So what we've done, you guys have all played with your devices. You've all seen this Metro-style application. And hopefully, like I said, you've seen our live tile activation. Again, back to this normal world of what we have today, you have to download a specific executable. You have to install an application on your device in order to communicate with that module, be it internal or external. In a tablet environment, of course, that's a preload by our OEM. But again, that certification process has to happen prior to us going to market. So what we can do in Windows 8 is we can integrate this live tile, this Metro-style application. And instead of us relying on the OEM and that partnership to integrate drivers and integrate firmwares and SDKs and APN selections, all that complexity, we're relying on Windows 8 to do that heavy lifting, right? So we've integrated into the Windows Connection Manager. And as you can see here, the available networks, we've got branding in here. AT&T's Globe is able to be in here. We're able to put our notification of what you're selecting as an AT&T customer. You're able to see this. And when you go to connect, behind the scenes, the device actually will recognize what state that SIM is in. And our application will take information from that SIM, validate what state it's in, whether it's been activated before or not, whether you've gone through our BiFlow pages where if you've activated before, if you've created a username and password, and allow you to now connect to this, what we call prepaid, this session-based pricing rate plan. So as you go through and want to activate, you don't have to rely on that agent behind the counter, right? You don't have to be in one of our stores relying on an agent or calling our customer care centers to have to activate. You can be off the grid, so to speak, within our coverage area, and have the ability to connect to our BiFlow page. I'm not going to go through an activation here. I don't think anybody wants to watch me key in a bunch of text input. So I just wanted to show you how this, in that background, our application was validating the state of that SIM. It's determined that it was not activated, but it's what we determine. It's kind of the code word. We say warm. There's cold SIMs, warm SIMs, hot SIMs. Cold and hot is what we kind of know today, right? It's either on or off. It's either been activated and it has an APN and a phone number provision to it and it allows you to get to our network, or it doesn't. Warm is basically the SIM is activated, but it only has access to our BiFlow page. So it's like a very defined walled garden. So if you haven't gone through this process on your device, this is exactly what you'll do. You can either go from the tile itself, from the live tile. You can notice how the live tile changes. It knows the state of the SIM, and it says, hey, what would you like to do? I'd like to activate my SIM. I'll show you in a moment. I'll switch over to an actual activated device, and I'll show you how that live tile can change. And I actually can show details about your plan and usage and information. So we've adapted to the functionality of Windows 8 and allowed ourselves to communicate to the customer what's very important to them. Again, in this scenario, the state of their device and that they need to activate. So let me switch over to an activated SIM real quick. So there we go. So now, when I launch that live tile, when I go back into this device and I power it up, this application wants to show us now information that's very important to the customer. So as you can see, we've broken it up into really 3 key categories. Details about your plan. In this scenario, I put a postpaid SIM in. I wanted to show you some additional detail than what you'll see on your particular development machines. You'll have prepaid SIMs. You won't actually have this level of detail on usage meters just because of the state of the application as it exists in the time we had to ship these devices to you guys. So this is the level of detail our mutual customers will have when we go live with Windows 8 and they get their hands on devices. So left-hand side, details about your plan. What's your bucket of bits? How many megabytes, gigabytes have you purchased? Obviously, I've got a 5 gig plan here. You can go back, you can see the link to manage my account online. So obviously that takes you back to our BiFlow. You could, on a prepaid environment, you could one-up your plan and stack your plan, add more data to your existing account. If you need to call us, obviously our support number right there. Wireless number, a lot of people get thrown off by this. It's like, well, why is there a wireless number? It's a computer, it's a tablet. I can't make phone calls on it. The phone number, of course, is the association to the SIM. And a lot of times, we've got specific call centers that will have dedicated support for specific products. And that phone number will be asked by our IVR system in order to route you appropriately. So some very key information for customers, just on that left-hand pane. My personal, I think most important feature, is this usage summary, and it's what we call usage meter. In a prepaid session-based pricing scenario, you've bought a bucket of bits. You've got a capped plan. It's not you don't usually typically have a large amount of data. 2 gigs is what we've given you guys for free for 12 months. You can burn through 2 gigs fairly quickly, right? Everybody knows that. So we want to give you the opportunities to see and really monitor where you're at. And if you can notice, we've really broken this down in like 4 different ways. Depends on how your mind looks at things, right? Some people just want simple days. I've got 3 days left. I've got 4 days left. I've used 27 of 30 days. Others want to see, well, okay, I've got a 5 gig bucket, so how much have I used? And, the green bar, obviously, 3 gigs, 3.02 gigs out of 5 gigs. Others, okay, what percent, how many, what's my percent left? So 39% left. And then we just call out, like I said, the exact bill cycle data when that swaps. So very key information for customers to monitor where they're at. And I wasn't able to pull a live example of this without just burning data. So the notifications tab is basically we've, again, built into Windows 8 to interpret SMS messages that are coming into the machine by our billing system. They're actually encrypted messages that we interpret and are able to present a toast message. So again, that Windows 8, that main screen, you're in any application, you're going to get a toast message, and they're warnings about your plan. So you're nearing your plan, you're 90%, or you're at 100%, you've just maxed out if you're on a postpaid. So again, all of this is about simplifying the world for the customer, right? ACM, AT&T Communication Manager, in our current environment is a very complex, very robust client, has lots of features and variables and things you can configure and adapt. We wanted the Windows 8 environment, we wanted to leverage Microsoft's great work that they've done in this space and just tie into all the things that are there, that we don't have to go through huge certification processes and all the things that I talked about. The value of keying in some of this key information for customers of what's important to them without interfering with the customer, right? These are things that just come at them naturally. They don't have to go in and enable or disable or modify or adjust. It's just notifications that they can get that are the thing, like I said, that are things that are very important to them. So this is our version of the Metro Style app. I wanted to show you guys live. Hopefully you guys will have a chance to get activated before you go home. If you have any questions at all, if you have any concerns, swing by, see us at the booth. We'll make sure you get going. I guarantee it. Excuse me, before you get back on your planes. Samar, I think that's it, my friend. I will pass it back to you, and we'll look forward to questions and answers after.
Okay, thank you, John. Thanks for sharing your experiences, and we definitely appreciate the work you've done to get into the build image and to give us free data for a year. That's great. Thank you. Thank you so much. So let's recap a little bit in terms of what you just saw John talk about. In order to build this differentiated experience, first, there's the AT&T network, which is an existing network. There's also a device involved, and the device should use the mobile broadband class driver. The device could be embedded in a PC, or it could be a USB-based modem device. And there's a custom app that you have written, a Metro-style app. These are the combination that creates a differentiated experience on top of our mobile broadband platform. And the glue is what I like to call it, that ties all of this together is device metadata. This is a description of your network service that Windows understands, and it allows Windows to connect your Metro-style app into the connection manager and to access some of the key APIs that Dheeraj is going to talk about later. Right now, I'm going to focus on the app. What are the key scenarios that you should think about as you build your Metro-style app? The first one is plan purchase. How do you get users onto your network? How do you get them to adopt your network service? You build a purchase experience inside your Metro-style app. When you do that, the Windows Connection Manager, when users connect for the first time to your network, the Windows Connection Manager, through the metadata, can launch your Metro-style experience, and your app can determine whether to show a purchase experience for this customer and how to proceed. We really want you to follow the design guidelines that Jensen talked about on the first day for Metro-style apps. We think doing that creates a really rich experience that goes along with all the other apps users are going to be using in Windows 8. So we think it's very important that you follow those style guidelines when you build your purchase experience. You can simplify the purchase experience by retrieving device information from the mobile broadband device. You can get things like the IMSI, the IMEI, subscriber ID, other information that your network needs to get activated so that the user doesn't have to enter as much information. You can also provide information to Windows to make it easy to connect. You can do this through XML provisioning, which Dheeraj will talk about later. And you can integrate with your existing purchase backend by using the SMS or USSD or web services. These are all things that the Windows platform allows you to integrate. Once the customer has bought a plan or topped up, if they're already activated, they're going to want to view their data usage so that they can figure out how far along they are in their usage. They may want to manage their bill. These are things that you can add into the Metro-style app because you control that experience. You can also enable custom branding and really show your own style and your own brand within the app. We have data usage APIs that give you local data usage estimates. You can make use of those to combine local counters, which are in a real-time type counter, with back-end information that you can get from your back-end. So when you combine those together, you can build a really good data usage experience for your customers. We think that building help and support into the app could be one way for you to reduce support costs, especially if the app has intuitive ways to get self-help, if it has FAQs, if it has common problems that you know this type of customer has. You can build specific solutions based on the mobile broadband APIs and the hardware information you get out of our APIs. So that's an example where you can really take advantage of the things we've built, the APIs we have, to deliver a customized experience. One of the key things with mobile broadband is you as a network operator being able to communicate back to the user. So common things could be that you're approaching your data cap, maybe your plan is about to expire, maybe you've entered into a roaming situation where the user might be charged extra money. And so there's things that your app can do to be aware of these. So even when your app is not in the foreground in Windows 8, you can make use of background events and listen to things like SMS or USSD channels to show notifications through our Windows 8 Toast UI. With operator provisioning XML, the provisioning XML, that is what the app can create. It's an XML package that Dheeraj will talk about a little bit later. And that allows you as an operator to define which SMS messages come from the operator. You can define the from address for SMS messages, and those will get routed to a special, so they're marked as operator messages so that your app can treat those and show those in the app if it wants to. We do recommend that operator messages get shown in this app. So one of the key things that you should have picked up on by now is that the Windows Start screen is really where the party is at in Windows 8. That's where a lot of stuff is happening. That's where the apps get to show themselves, and that's where users really get to customize their Windows 8 PC. And so we really encourage you to make use of that really great real estate, that really great opportunity to show user-relevant information in a dynamic way. You can detect the state of the SIM and show the user that they need to get activated. You can show them plans that are relevant to the user, that are available to them, and you can highlight your brand. And we think that's what makes this really compelling, is putting together the great things in Windows 8 with our mobile broadband platform. And as I mentioned before, even if your app is not in the foreground, you can still use background events, which you can code, to listen for things like connection status changes. You can listen for data usage updates or other SMS or USSD notifications. And you can invoke a notification through our Windows notification UI. And so those are the scenarios that we think are key to delivering a mobile broadband Metro-style app. And it's great that I told you about these scenarios, but now I'm going to invite Dheeraj Gandhi to come on stage and talk to you about how to implement these and make them a reality. So Dheeraj, come on up. Thank you, Dheeraj.
Can you hear me now? Okay, thank you. So again, my name is Dheeraj Gandhi. I'm a program manager in a wireless and networking services team, and I work on the mobile broadband platform for Metro-style application. So I'm going to go through details about how you can build the applications, how you can provide a metadata to Windows system. So let's start with APIs. One of the key strengths of Windows platform is provide you the great APIs that you use for building your application. As a Metro style app, you will have access to all the APIs that Windows provides. The UI, user interface APIs, the other controls. And what I'm going to showing on this screen is the important API associated for the mobile broadband app. So let's start with APIs. First API I'm going to talk about is the SMS API. As all of you know, SMS means short messaging service. This API will allow you to create a complete SMS client inside your application. This includes sending an SMS message, receiving an SMS message, as well as accessing the device storage. With this SMS API, you can receive operator notifications also. This SMS API has a background functionality. Even if your Metro app is not in the foreground, still you can receive the events from Windows when your device receives a new SMS message. Next one is the USSD API. USSD is unstructured supplementary data services. It's a long name. It basically is a popular standard in GSM that allows the device to exchange short amount of information with a real-time session with their backend. In Windows 8, we have created a simplified USSD API that implements GSM USSD protocol. This API allows you to create a USSD session, send a message on the new session, as well as receive a USSD notification. Similar to SMS API, USSD APIs also enable background functionality. You can receive a USSD events even if your app is not in the foreground. As a mobile broadband Metro style app, you need to know what is the connection status of your device. And you can get the connection status of your device using connection status API. This API tells you whether your device is connected to the internet, whether it's not connected. This API provides the events to your application. So your application can detect the connection status changes. This also API also has a background functionality. So your app will able to receive connection status event even if your app is not in the foreground. Samar talked about two key scenarios, a plan purchase scenario and a help and support scenario. Both the scenario require device information, and device information such as IMEI of the device, MEID, IMSI of the device. And this information you can get using subscriber and device information API. If this API information is not available to the app, your app has to manually ask this information. We would like to avoid the manual entry and give a user a simple experience using this API. Just a quick question. How many of people attended yesterday's mobile broadband talk given by Mike and Srini? I think quite a few people have attended this talk. So in that talk, we talked about Windows mobile broadband connection, mobile broadband class driver. This class drivers enables a simple connection experience. Also, this class driver allows you to extend this functionality with your own unique and differentiated services. Device Services API gives you that ability. Device Services API provides you a pipe that goes from your Metro style app to the device. You can create a unique scenario. You can do whatever you want to do with these APIs. This gives you a flexibility to create your unique and differentiated scenarios. We talked about data usage scenario. When the user goes and checks the data usage inside the application, you can get the data usage from the server, but that will increase the loading on the server. To reduce that, we are providing a local data counter API. This API provides the ability for you to query local data usage on your device up to 60 days. So you can combine the server data usage with the local data usage to show user an actual close to real-time data usage information. The next one is the data usage API. In various sessions, we talked about Windows cost-aware networking. This cost-aware networking enables Windows to behave smartly on mobile broadband network. This includes projecting the data usage information to a metro-style application so that they can take a smart decision on mobile broadband, such as if you are near to the camp, they don't want to download a large file. So to enable this behavior, what we are expecting operator apps to provide data usage information. If operator app provide the current data usage information, whether the user is at 20% of the cap, 30% of the cap, 40 or at 90% to Windows, Windows will project that information to other metro apps as well as Windows will use that information. So we'll like you guys to take advantage of this API. And the last API is the provisioning API. This API allows you to provision provisioning metadata to the system. And I'm going to cover the provisioning metadata later in the section. One key point about this API, mostly the API associated with the mobile broadband are restricted APIs. Only operators app have access to these APIs. Other apps such as a news or a game, other apps will not have access because we want you to control your mobile broadband device. Now, I would like to show a couple of samples how you can use these APIs. This is a very simple sample, and this shows how you can access a device information. This code snippet shows how you can get various device properties. As you see from the sample, you call an API, get the information in the variable, and you can get various properties from this API. The properties I am shown over here, device ID, which is either IMEI or MEID, subscriber ID, which can be IMSI for GSM networks, phone number, SIM ICC ID, or device model. This is just a sample set of properties. To see a complete list of properties, you can go to our MSDN documentation. Another code snippet I want to show is how you can send a USSD message. This is a very simple code snippet which implements a complicated USSD functionality. From your app, you can create a USSD session, associate a text of a USSD message to it, and then you send a message and wait for the reply. Once you receive a reply from the network, Windows can encode that message and provide you a plain text message. This way, your app doesn't have to implement complicated decoding mechanism. Samar talked about earlier how you can build a differentiated mobile broadband experience. This involves 4 components. Your great mobile broadband service, a removable or embedded device that is compliant with Windows class driver, a metro-style app that we talked up till this point, and device metadata, which glues all these things together. And now, I'm going to concentrate on device metadata. There are 3 types of device metadata we have in Windows. First one is the APN database. This makes a simplified first-time connection experience. This makes user for easy to get connected. This is a built-in database inside Windows generated by the data provided by operators. Second is the experience metadata. This is the operator-specific metadata downloaded on Windows whenever operator hardware is detected. This metadata enriches Windows connection experience with your own branding. And the last one is the provisioning metadata. This is a subscriber-specific metadata. This has subscriber-specific data, such as subscriber credential, APN associated with the subscriber. And this 3 creates a device metadata story. And now, I'm going to concentrate on each of these metadata. Let's talk about APN database. As all of you know, when a user tries to connect to mobile broadband network for the first time, he has to supply APN or accessing information. And this information is not easily available. Either user has to go search on the internet and try to find this information. Or if he can't find the information on the internet, he has to make a customer service call, which is a very costly operation for the partners. So what we have done, we have basically gathered the data. We need to gather the data from you, which contains operator identification codes, such as your IMSI ranges, SIM-ICC IDs, MNC or MCC IDs. And we will associate that with the list of APNs that you will provide. You can provide a friendly name associated with the APNs also. This way, user can see a simplified name for APN, like whether this APN associated with the postpaid subscription, whether this APN is associated with the prepaid subscription. So with this data, what will happen is when user tries to connect to the mobile broadband network for the first time, he will see appropriate APN associated with his mobile broadband hardware. So he doesn't have to go on the internet to find it. And he can look at the appropriate friendly names like a postpaid associated with his PAN and easily get connected. The one last point also is contained in the APN database is a URL for web-based purchase experience. In certain cases, your app may not be installed on the Windows. The cases are when user goes to a foreign country, he has a USB device, he plugs the USB device to the Windows. And if Windows doesn't have any internet connection at that time, Windows may not able to download the app. But we will like to get user connected in that scenario. For this to enable that, we are providing a URL inside APN database. So what happens is user can go to the browser using the URL inside the APN database and he can purchase the subscription. This is similar to what you see on the Wi-Fi captive portals today. So this APN database data is provided by you. You can provide us the data and you can update the data. As an operator, whenever your APN information changes, you have a new APN, you change the APN name, you need to go to Windows Hardware Development Center. And using that interface, you can provide a new updated APN information. Once we receive that information, we'll create a Windows Update package. And this Windows Update package will be downloaded to all Windows PCs. This way, Windows will have up-to-date APN information whenever you change your APN. And user can use that information. We talked about APN database. Now I'm going to switch to the experience metadata. This is an operator-specific metadata that enables the branding inside Windows connection experience. You saw the demo that John showed, where you can see a AT&T logo in the Windows connection experience. And this is enabled using this experience metadata. Also, one of the key benefit of Windows mobile platform is automatically downloading your Metro style app. Whenever your mobile broadband hardware is detected inside Windows, Windows will download your mobile broadband app. And this is enabled through experience metadata. Experience metadata contains your application ID for automatic download. We talked about the rich branding that you can enable inside Windows Connection Manager. And this rich branding consists of your icon that appears inside the Connection Manager, as well as your customized name of the network. The name of the network coming over the air or stored inside the device, if you don't like it, you can provide us an appropriate name and we'll customize that to show inside Windows Connection Manager. Some of you have a purchase APN, which allows user to have a limited connectivity for purchasing the subscription. And this information is enabled through experience metadata. Using experience metadata, you can provide a purchase APN. And Windows will store that information, and when user tries to connect to it, will use it. We talked about identifying the operator. Windows will automatically identify the operator whenever mobile broadband hardware is detected. And this identification is done using the data that has been provided by you. Your IMSI ranges, your SIM-ICC ID ranges, or your MNC ICC code. We'll use that to determine the operator and associate metadata package for it. We talked about restricted APIs, only your app having access to certain APIs. You might want to develop more than one app. And if you are developing more than one app and you want to access a mobile broadband device, you can specify the application IDs for those applications using experience metadata. So let's look at that, how this automatically detection of download of metadata works. Whenever a Windows detects a mobile broadband device, Windows will identify operator associated with that device using the IMSI ranges, SIM-ICC ranges, and it will provide that information to Windows metadata and internet services. This is the cloud services stored on the internet. And once that service gets the data, it will find appropriate package. It will find the package and provide that package to Windows. And Windows will have your experience metadata. Within this experience metadata, we have an application ID for your Metro style app. We'll use that experience metadata, go to Windows Store, and download your Metro style mobile broadband app. This way, whenever mobile broadband hardware is plugged into Windows, Windows has your custom experience as well as your differentiated app. And you don't have to maintain or deploy this thing. This will happen automatically. We talked about Windows built-in metadata, operator-specific metadata, and now is the last part of the metadata. It is the provisioning metadata. This enables operators to provide subscriber-specific information. The information is typically determined after the user has purchased the plan. Provisioning metadata is an XML document. It is provided to Windows using provisioning APIs. The subscriber-specific information, I'm just showing some example of that subscriber-specific information over here. This can include your user-specific APN, user-specific access string, user-specific NAI. This can also include Wi-Fi hotspot information, the SSIDs of your Wi-Fi hotspot where you will like to offload the traffic, the whisper credential associated with the hotspot, as well as the user's plan information. We talked about cost-aware networking, and this cost-aware networking is enabled through plan information. You can specify whether the plan is a variable plan, whether the plan is a fixed plan, or whether the plan is an unlimited plan. And Windows will store and use that information to enable a cost-aware networking. Let's see how this provisioning metadata gets applied to Windows. As an operator mobile Metro style mobile brand app, you control this metadata. You can provide this metadata to Windows using Windows provisioning engine. There are two ways you can get this data from the backend. Whenever a metadata changes on the backend, operator backend can send a notification to your app. It can do that through Windows notification service. It can do that using SMS or USSD messages. And then your app can receive that message. It can go to the backend, get the updated information, and update Windows with the provisioning information. Or your Metro style app can periodically query the operator backend and see whether the information has changed. And if the information has changed, it can download that information and provide that to Windows. This way, user will have a seamless connection experience. Even if user's credentials or any stuff changes on the backend, Windows will have that information. And the user doesn't have to make a customer support call or find on the internet what's happening. We talked about last 45 minutes about mobile broadband Metro style app. And now I'm going to recap this thing in one simple statement. What Windows 8 does, Windows 8 allows you to differentiate their offering. And while it's going to provide user a seamless connection experience, you are going to develop your own Metro style app. This app you control. You can develop new scenarios. You can develop your existing scenarios inside that app. You own every pixel of that app. So you can develop your own differentiated offering. As well as with Windows, we have invested a lot of resources to develop a seamless connection experience for mobile broadband. And this gets integrates very well, having a link of your app from the connection manager. The opportunity is Windows 8. As an operator, you can create an integrated experience with Windows Connection Manager by developing your Metro style app. This Metro style app can have all the scenarios you wanted to develop, and it is very well integrated with Windows Connection Manager. As well as you can provide a metadata, APN metadata, experience metadata to simplify the connection experience for the end user and enable rich branding inside Windows. And these are the list of the sessions associated with Windows mobile broadband. I think most of this session has already happened. I just put here so that you can go, and when you are developing the app, you can watch the videos associated with these sessions. And this is the list of the documentation that will be very helpful when you try to develop a mobile broadband application. And this includes the API, how we can provide the operator experience metadata, and as well as how we can onboard the operator. And if you have any question while developing the app, you can contact windowswireless@microsoft.com. Again, thank you for listening to our presentation for last 45 minutes. If you have any questions, we can answer your questions. Samar, can you please join me on the stage?
Hear me?
Yeah.
So the new Metro APIs that you mentioned, those need to communicate to devices that support the new USB class driver only. Is that correct?
That is correct. Eh?
So if you want to write a Windows 8 Metro UI app and you want to also interface with legacy devices, can you still have that information in your tiled app using more legacy proprietary interfaces from device OEMs? Or do you have to keep a separate connection management app to support legacy devices?
So this is interesting. We need to understand your scenario much better. I can't comment just like without understanding the scenario. But for the Windows 8, the devices that you are building, we will like to enable a class driver. So using a class driver, you will have access to your normal functionality as well as if you want to add new functionality. And for the legacy devices, we can discuss further.
Yeah, so the scenario is somebody already has a mobile broadband device. They decide to get a Windows 8 machine. You want to give them, the operator wants to give them that same Metro UI tiled experience with their legacy device. They obviously can't, that device doesn't support the USB class driver, so how do you do that? That's really what
Okay. Yeah.
Darren, come on up and answer on the microphone.
Yeah, you can use this.
So as long as your device supports the WWAN driver model from Windows 7 and Windows 8, the driver model hasn't changed. These APIs are still available, with the exception of device services and USSD. Well, USSD is, as long as the driver implements the DDI contract, that would be available too. So device services then would be the only one that's not available.
Okay. So there is a path for that scenario. Yes, in the back.
I had a question on the APN database.
Yeah.
Okay.
So is it possible for the connection manager application to change the APNs on the fly? For instance, if you take the AT&T connection manager, the consumer purchases a plan, and now the SIM is hot. He can browse and everything.
Yes,
at some point, the SIM becomes warm. Now, just to activate and go to the plan page, the APN has to change.
Yes. To the provisioning metadata, you can specify two APNs. One for your connection, like internet APN, as well as you can specify the purchase APN. And like from the AT&T example, when you are connected to the internet, we will use the connection APN. And when your plan expires and you'd like to purchase the subscription, we'll use the purchase APN. And you can specify that using provisioning metadata.
Okay. My second question was on the device services APIs. So you mentioned it can be used as a direct pipe from our app to the device. So is it something like a binary blob that you can throw to the device, and it's up to the device how to interpret that and provide a response? Is that?
That is correct. And we talked about yesterday, there are 4 types of the operation you can do. You can register for events. You can enumerate what services that device provides. You can query the services, and you can send or receive the data. So you have very good flexibility of developing solution associated using this API.
So can we call it, okay, I'll tell you how it is normally. For special proprietary stuff between the application and the modem, sometimes we use the modem port, the COM port, to send 80 commands and get something back. So is this something, a backdoor for Metro style apps to use for that scenarios?
From the Metro style app, you will not have access to your COM port
or
your AT command. So you can define your string or whatever the commands that device understand, and you can do using this API.
Okay. Last question on the. You presented a scenario about a user roaming to a different country and having to download the application before his USB stick. So presently, most of the USB modems, they come with onboard connection manager applications. So they have ISOs, which are auto-installed CD format. So can a Metro-style app be installed that way? Or does it always have to be through the distribution channel from live?
That is not supported. Using USB storage to install Metro apps is not supported.
So a mobile broadband app has to be approved. I mean, it has to go to the channel to be distributed via the live framework.
To the Windows Store.
Windows Store, okay. Thank you.
Any other questions? Yes, over here.
You can come.
Can you come to the microphone, please?
Do you plan to develop API for MMS services?
So what we think is that we have most of the APIs, like HTTP APIs, SMS APIs, SMS notification required so that you can build your MMS client inside Metro style app. And we can discuss this further. Okay.
Any other questions?
Sorry. I had an extension to the question that the other gentleman had about supporting legacy modems. So I have a Metro style app which will work with the new generation of mobile broadband class driver compliant devices. So now I didn't understand your response to that. So can I use the same app to talk to a non-compliant modem? Can I take an existing USB modem from today's market, plug it in, and have my Metro style app talk to it through the same Metro style APIs?
If you have mobile compliant driver, it will work. If you don't have mobile broadband compliant driver, the app will not able to talk to the device.
So when you say compliant driver, you mean the class driver with Windows 8 or Windows 7?
Windows 7.
Yeah.
Yeah.
You will be able to use the Metro style API.
Okay.
Whether it's a class driver or device manufacturer.
Yeah.
So it's just a logo font.
Yeah.
Okay.
So let me just repeat Srini's answer so everyone watching on the web can actually hear that later on. You need to have a driver that is mobile broadband logo compliant in order to use a Metro style app with your mobile broadband device. It doesn't have to be the class driver. It has to be logo compliant.
So the current Windows 7 compliant drivers, they just carry forward, or do we have to re-logo, recertify them with the new logo?
So the existing drivers that you have invested in, or the device ecosystem has invested in, they will continue to work as is.
Yeah.
In order to light up all the new Windows 8 scenarios, you might want to consider adding the driver, migrating the driver to Windows 8, Windows 6.34 compliant.
Okay.
And if you're doing a new logo, we would highly recommend you to
Class
create
driver.
a class driver as a path. There are a lot of users.
Okay, so to summarize for those at home, Windows 7 compliant logo drivers work, and we encourage you to move towards the class driver model going forward.
Thank you.
Any other questions? Yes, in the very back.
There was mentioned that the APIs are restricted unless you have an app ID. So what is it like? Are all the mobile broadband calls restricted unless you have an app ID, or it's just certain classes of calls? And how do we get an app ID?
So I'll try to answer your question, and Samar or Darren can add it. So the thing is that to access certain mobile broadband APIs, like a USSD API, the device services API, and the device and subscriber information API, those are restricted APIs. Only mobile broadband operator app can access to the device. So, and that app ID has to be provided by operator experience metadata. And that once the app ID is provided by the operator experience metadata, we allow that pipe, and so you can have the access. And you can basically, using like the same Windows hardware center, you can provide the metadata, and your app will have access to these APIs.
For local development, if you're locally developing, we have tools that plug into Visual Studio Express that allow you to generate these metadata packages locally so that you can develop and test this locally. So if you're a developer, if you're an ISV, you can actually develop one of these locally on your box without having to go through the full submission process to get your metadata approved. Now, if you do want to publish your app, that's where you have to be a mobile network operator or somehow have the approval of the mobile network operator you're working with to successfully submit the metadata that associates your Metro app with that network.
Okay. Sorry, one more question. So
Okay,
is it possible for OEMs to preload certain operator apps on the devices that they ship?
I think we're not talking about that yet. We can talk about it later. We'll be at the Ask the Experts session.
Okay, thank you.
Yes, right here in the front.
Actually, so far for the mobile broadband devices we supported, we used to install the drivers upon plugging in the USB dongle. After an installation of such an application, we used to uninstall the drivers. But what happens in this scenario in Windows 8? If user wants to clean up the drivers provided.
So this is for the legacy devices. With all the legacy devices, whatever you as designed as engineer for your company or team, so there is no change. So continue to work as all the new devices. We would recommend you to use the flash driver. It's one of the biggest reasons, as you said, you don't need to
Okay.
So to summarize for those at home, use the class driver. That's the best scenario. And Windows 7 style works the same, basically. Any other questions? As I mentioned, we are going to be at the Ask the Experts session tonight. So if you want to meet us and talk to us, we'll be there. So come by the mobile broadband area, and we can have more discussions with you. So thank you again for being here and spending your time with us. We really appreciate it, and we appreciate your questions. So thank you so much.